On this video, I'll be talking about the genetic code paper that we went over. That one, I'll go ahead and start with my personal opinion on that one. So that one was a little hard for me to understand. It had a lot of vocabulary, I guess, that was a little hard to understand. And there was a lot of abbreviations that were mentioned really far in the beginning of the paper that weren't reinstated like what it stood for, so I had to go back a lot of times to understand, like, or to remind myself, oh, that's what it stood for. So that was a little, annoying. And I also had to keep reading things over and over again to completely understand it. And so the actual paper, what it was about, it was by a guy named Bernardi. I believe he might be Italian. And what he wanted to do was determine how the structure of chromatin actually affected the DNA itself. And so he had these things called isochores. These are groups of homogeneous DNA, and they were categorized based on their GC or guanine cytosine content. So guanine cytosine poor isochores, they had low heterogeneity with the oligo A sequences, and they were corresponded with the lamina associated domains. These are also called LADs. This is one of those terms that I had to go back and look at the definitions multiple times. And they're located on the nuclear periphery and associated with closed chromatin states. So like when the chromatin's in its closed position. And then the high GC content, or GC rich, these are kind of the opposite of the GC poor in terms of, the characteristics of it. They are associated or corresponded with the topologically associated domains, also known as TADs. And then they're essentially located within the nucleus and associated with open chromatin states. So, when the chromatin is open. So there were a few things that he wanted to do. He wanted to evaluate like junk DNA. This is DNA that doesn't code for anything, and he wanted to know what this DNA was used for, like what the purpose of it is. And what he found out was that it actually does code. It does help the rest of the DNA. It helps the coding DNA with the structure of it. So if this junk DNA wasn't there, then the rest of the coding DNA wouldn't be able to function correctly because the structure of the DNA would be completely wrong. So yeah, that was basically the gist of it. Again, I could be a little off. I didn't understand it very much, and that could just be me. I'll totally take the blame for that, but I didn't understand this paper very well, and like I said, it was very hard for me to read. But I'll take it.